So good afternoon, or I think. So I will be talking on some different topic. It's on glass, and that is very close to our heart. We use every day different kind of mobiles. Mobile is having display, and we want a stronger display that it will not break. So scratch resistant, stronger display. How we can make? So that I am just going to present you. Okay. So it is basically some advanced version of Gorilla Glass. So all of you heard of Gorilla Glass, right? Gorilla Glass, you have idea some? So we are trying to make some kind of glasses which will be unbreakable and much stronger than Gorilla Glass. So how we can do that? So before going into the topic, I just want to give you a small introduction, what is glass? Because this audience may not be from the glass background. So you see there are three kinds of materials. Metals, ceramics, and polymers. So glass belongs to which category? Any idea? Glass belongs to which category? Ceramics, right? So mostly glass belongs to ceramics. So we can make glasses out of ceramics. So all these glasses, window glass, bottles, containers are ceramic material. But we also know that there are glasses, metallic glasses are also possible, right? So bulk metallic glasses are also possible, and polymeric glasses are also possible. So take home message is that you can make any material, you can convert into glasses, any material. If you can melt it, and if you can cool it faster than its rate of crystallization, you can convert any material into glasses. So it is not confined to metals, ceramics, or polymers. So any material you can convert to glass and you can get some unusual properties. Okay, so we understood that any material can be converted to glass if you can melt it and cool it faster than its rate of crystallization. So you can have bulk metallic glasses, now it is possible, which is having unusual strength. So glass is basically a non-crystalline solid, and if you see that crystal, this is a quartz crystal, it has long range periodic arrangement. But in case of glass, this long range arrangement is missing. We call it short range order. So if you can melt a glass and you can avoid the crystallization, at this point, we end up with a supercooled liquid. We call supercooled liquid. It is a liquid it's basically a solid, but having a liquid structure. So that's why we call it supercooled liquid. Sorry. So here one thing just I want to point out that if you can make a glass, same glass composition, if you cool it very fast and if you cool it slow, you will have different kind of volumes. So it will have different density. So those depending on the cooling rate. So same glass composition, different density you can obtain, and that actually used to engineer the glass surfaces to make it much stronger. So that I will explain it. So this is basically, these are the things, 5 kind of oxides we use for glass melting. I'm not going into details. And display, you know, there is a huge market. There is a market of around 1.42 billion US dollar. It is projected to rise to 1.97 US dollar by 2028, and there is a huge growth rate of CSIR of 5.7%. And there is no Indian manufacturer. Now there is a one company, India is manufacturing, but mostly it is from USA and China and other companies, they are manufacturing. So India, there is a potential for developing such kind of glasses. So one question is I just want to ask to the audience, can glass be made stronger than steel? Is it possible? What do you say? Possible or not? So it can be made possible. I will show you. If you see the theoretical strength of glass is 35 GPa, 35 GPa, and strength of steel is 0.4 GPa. So it is a glass theoretically 100 times stronger than steel. But we don't get that kind of strength because glass is having small micro cracks all over the glass surface because of the handling. So if you can achieve 1% of the theoretical strength of glass, you can have a glass as strong as steel. So glass can be easily made much stronger than steel, and there is a potential. You can make it, and that's why Gorilla Glass is upgraded. Now it is 7th and 8th generation. Gradually they are upgrading and they are making much stronger glasses. So glass, there is no other choice for display application because of its transparency. There is no other material, and also hardness. And mechanically weak and brittle, that we have to address. If we can make it unbreakable glass, then it's something will be very, very phenomenal. So there are different strengthenings actually to strengthen the glass surface to suppress the, minimize the defects in the glasses. There is micro cracks in the glass that actually reduces its mechanical strength. And I just want to show you that there are different techniques, like lamination is also one of the techniques. Multi-layer glass is used, and those kind of layers actually used for making bulletproof glass and skywork. I just want to show you one image. Oh, sorry. So this laminated glass is used in the windshield, car windshields. For bulletproof application, multi-layer glass is used, but there is nothing but a bulletproof glass. And also we use, the skywork is made of multi-layer laminated glasses. So those are that kind of reliability we have with glass, that you can walk through the skywork, standing at few kilometer height. Okay. So lamination is one technique. Then another is the thermal tempering. So most of the windshield of car is made thermally tempered to strengthen the glass surface. And a new technique I'm just talking about is basically, I will say, it's a glass ceramics that I will be mostly covering today. So glass ceramics is having huge potential for making unbreakable display. And this ion exchange technique is used for in Corning Gorilla glasses. They use ion exchange technique to strengthen the glass surfaces. They basically create surface compressions. So these are the Gorilla glasses we use mostly in mobile and tablets and this smart watches we are having. So these are the technique, mostly lamination, thermal tempering, glass ceramics and ion exchange are the techniques mostly followed to strengthen the glass surface. So I just in the beginning I was telling that if you cool it at same glass at different cooling rate, you will end up with different densities. If you cool it faster, you will have a lower density. If you cool it slower, you will have a higher density. So what happens, thermal tempering, the glass blocks is exposed to a high temperature and suddenly quenched it. So as glass is a thermally insulating material, what happens, surface cools very fast compared to the interior. So there will be different kind of density than interior and the surface. So because of the density difference, it pulls the surface and creates some kind of compression, and that strengthens the glass. So that we call thermal tempering. So in chemical tempering, what happens exactly? There is a sodium ions here in the glass, and that is actually exposed in the potassium nitrate solution at high temperature. Smaller sodium is replaced with the potassium, bigger potassium ions. So this bigger potassium ions actually creates a surface compression. So small cracks that is already present in the glass surface, that is actually compressed, and it gives you a lot of strength in the glass. And Gorilla glass is mostly relied on this kind of technique, right? So I will show how Gorilla glass is made also. I'll show. So this is basically Gorilla glass, and I will be talking mostly on glass ceramics. So glass ceramics, that also I will explain, but essentially glass ceramics is glass. Within the glass, you are having small crystals. So small crystals are dispersed in the glass. It helps deflecting the cracks, and it strengthens the material further. So it is more stronger than the glasses, normal glasses. So actually Gorilla Glass was made in 2007. So this man, you know, his name is Steve Jobs. So he actually made a call to the Corning CEO. Corning is a US giant glass manufacturing company. So he told, before launching the first iPhone, he told, can you make some glass which is crash resistant and unbreakable, or much stronger than the normal glasses? So that Corning took up the challenge, and they produced the glass in 2007, right? And now today there is 6 billion users worldwide of this kind of Gorilla glasses. So this is basically glass ceramics. I will give just brief introduction. So what happens in glass ceramics is a polycrystalline solid prepared by controlled crystallization of glasses. So your starting material is glass, it's completely homogeneous glass, and we give some thermal treatment to give some kinetic energy to nucleation and crystallization. So by this process, some crystals, nuclei is formed and some crystals are generated, And we basically get this kind of glass, completely transparent, it converted to opaque glass ceramics. So depending on size of your crystals, it can be opaque, it can be translucent, it can be transparent. So if you can control the crystal size in nanometer scale, then you can make transparent glass ceramics, and which is much stronger than the glasses. So I will show you some examples. So there are some challenges. Basically, when you induce some crystals in the glass matrix, the transparency is going to be lost. So you have to control the crystal size precisely nanometer scale so that transparency is retained and it is useful for display applications. And mechanical properties also you have to maintain very high. So in order to achieve the transparency, you need to control the size of crystals, and also defect index match between the glass phase and your crystal phase. If you can match it, then you can also have a very good transparency. Okay, and also for mechanical property, you need to have homogeneous distribution of nanocrystals, desired crystal phase, and surface strengthening. Also, ion exchange you can do with this kind of glass. Okay, so these are the things, molecular dynamic simulation and crystallization kinetics study that actually helps in control crystallization. So how we do actually, if you have to ensure a large number of nuclei formed in the glass matrix. So if you have a large number of nuclei, then the crystals will grow in a very small size and uniform size distributed throughout the matrix. But if you have only fewer crystals like this, then your crystals will be much bigger and it will be dissimilar size and mechanical property will not be strong. So there is some techniques so that you can ensure that large number of nuclei is formed. So we can do it basically through DSC studies. We can do some kind of analysis and we can basically determine experimentally the temperature for maximum nucleation. So that I am not going details into theory of that, but you can measure, you can determine the temperature for maximum nucleation, and you can ensure large number of nuclei in the glass matrix. And also, in our laboratory, we have done DSC and crystallization kinetic studies to basically determine the isothermal crystallization rate. We can determine at different temperature. So for this glass, we see at 700 degrees centigrade, there are around 300, 400 minutes you are having in your hand for complete crystallization. So you can control the rate of crystallization and control the crystal size. So those are the techniques. Crystallization kinetics helps you to control the crystallization size of the crystal that we are precisely doing in our laboratory in CGCRI. So these are the problems, and we mostly worked on spinel glass ceramics, magnesium aluminum spinel glass ceramics. We have worked 5 minutes. Okay, done. So in case of ceramics also can be much stronger, but it is more costlier, and you cannot make large size. For your TV display or any other big display, you cannot make ceramics. But ceramics is also having a transparency issue because of there are pores and impurities. That is actually missing in case of glass ceramics. There is no pore and no impurity, only small crystals are there. So that will be basically, as it is very small, you are going to have some kind of transparency that is useful for display applications. So I will just show you some examples that if you say this kind of composition, so base glass is having the fracture strength around 146 MPa. When it is made to glass ceramics, you are inducing some crystals, generating some crystals in the glass. The property is 251. There's a huge jump in mechanical property. And when this glass ceramics is again ion exchange, it is down to 487. So there is a multiple few order of magnitude increase in strength. That is possible with the glass ceramics, and that is again ion exchange. So you can, in future, you are going to have some kind of glass which is really unbreakable and you cannot break it. So these are some examples I just want to show that in case of glass, in case of glass ceramics, in case of glass ceramics ion exchange, there is a huge jump in mechanical property, right? So that is going to be the future of display material. So we have worked on magnesium aluminum spinel glass ceramics, and there is quite transparent. If you see the soda-lime silicate glass, the property set of properties like hardness, Young's modulus, fracture toughness, there is a few orders of magnitude increment or enhancement of strength that we could see. And we have maintained this kind of, produced this glass ceramics with the highest level of transparency. You can see the transparency is around 85%, more than 85%. So this is more than enough for display applications. And how we are getting this kind of high level of transparency? Because we could control the crystal size. You can see it's a nanometer, so this is 20 nanometer bar, and you can see it's a 15 to 20 nanometer. So this kind of precise control of crystal size we can do, and it's homogeneously distributed throughout the glass material. So that gives this kind of mechanical property, and that's basically going to change your future of display technologies. So we have also worked on lithium aluminum silicate glass ceramics, and we have started working on this, and we found that if you see that in case of glass, there is some property when it is made glass ceramics, the property is enhanced significantly, and we have not done the ion exchange yet, but we are expecting much stronger glass ceramic with the highest transparency, very good transparency. So this is my all I want to share. I acknowledge my colleagues here and SCRB and DRDO for their generous funding. Thank you all. If you have any questions, we can discuss.